All right, guys, welcome to Algebra 2. Where we left off the other day was talking about the differences in permutations and combinations. So we said, and I'm going to write this up here just so we can keep it straight in our heads, that a permutation is where order matters, right? You have groups, and the order of which you select the people is important. A combination is the other way around. In a combination, order doesn't matter. So again, just to give us some examples to get our thinking about it the right way, if you have a race and you're seeing how people finish in it, or what the order people finish in, the order they finish, the order we choose this or can find this permutation of the group, first, second, and third, is important because it's different if a person finishes first to if they finish second or third, that kind of thing. But a combination doesn't matter. If we're choosing 10 people out of 1,000 and each one gets $50, well, does it matter the order we choose them in? No, because every single person, all 10 of them, is getting the same prize. Every one of them is getting $50, right? They're all the same, as where first, second, and third are different. A way I like to think about it is if you have a question that specifically has names or something like that for the things we're choosing a this, a this, and a this, it's a permutation. That is important for the order. If it just says, we want a group of these people, doesn't matter. We just want 4 of them. That's probably a combination. But let's look first at the permutation part of the page. So, because that's what comes first on your packet. So, there's an equation I'm going to give you guys. But before we do that, we are going to talk about a couple variables that we see. So, a permutation formula is written like this, NPR. Now, I know what you're thinking, National Public Radio. It's not what this stands for, though. The P stands for permutation. N is the total number of objects, people, things, whatever, right? The total number of whatever we're dealing with. R is the number we want to select. So using that race example, if we have 20 people in a race and we're just awarding first, second, and third, then we would have the N value be 20 because there's 20 people participating. And the R value would be 3 because that's the number of spots we care about, right? So let's read a problem here and then we'll talk about the actual formula for it. So it says, how many ways can you arrange the letters in the word dinosaur? Okay. So it's interesting, right? So we're talking about the letters in the word dinosaur. Well, how many letters are there? Well, by my count, we have 8 letters. I'm going to write that here. We have 8 letters, so that is going to be our value of N. There's 8 total objects that we're trying to move around. Now it says we want to arrange them. Well, do you think order matters there? I mean, we already know it's a permutation because it's in that section of the paper. But let's think about why it's a permutation. It's a permutation because we're arranging them. We're trying to put them in order, right? In some sort of an order. If you're arranging things, in my mind, naturally, I start thinking order is important. Because if it doesn't matter what order they're in, then why are we arranging? I don't know, that's just what I think. But how many are we arranging? Does it specifically say how many arrangements of 3 letters can you use? Does it say how many arrangements of 5 letters? No, it says how many arrangements of all the letters. So in this case, R, the number of letters we care about, or the number of objects we care about, is also 8. That's what's really important. To determine how many we have, how many we care about. And in a question like this, we care about all of them. So we're going to go to the formula for permutations. This is where it gets crazy. The formula for permutations is n factorial. We talked about factorials the other day. You take that, whatever number you have, and you multiply it by each number smaller than it, right? And you divide it by, in parentheses, n minus r factorial. It's important to notice that the n minus r is in parentheses. You subtract those two values before taking the factorial of the number. So in this instance, you're going to need to use factorial, so if you have a calculator that does that, awesome. Otherwise, on your phone, you may need to download a program called GoodGrapher. It's a free calculator app that'll let you do it. But we get n, which in this case would be 8 factorial, divided by n minus r, well, 8 minus 8 factorial. That's a weird exclamation point. I acknowledge it. So 8 factorial is going to be 40,320. Let me write it up here. Now here, before we take the factorial, like I said a minute ago, we need to subtract those numbers. 8 minus 8. Well, that's 0, right? What's 0 factorial? I know, it doesn't make a lot of sense, but you remember it. It's 1. So 40,320 divided by 1. Well, that's just 4320, right? No difference there. So there are 40,320 ways that you could arrange the letters in the word dinosaur. That's insane to me, but it's true. Now let's look at another problem here. Example 6 says 7 students are competing in a geography meet. How many ways can they finish? First, second, and third. So let's write this again. NPR, right? I guess I didn't actually write this with the numbers in it before, but we'll do that this time. What is our n value? How many people are in this geography meet? 7. 7 students are competing. So n is going to be 7. Of those 7, how many do we care about? How many are we trying to find the places of? 3. First, second, and third. And again, this is a permutation because first is different than second and it's different than third, so order matters. So 7p3 is a shorthand way of writing this. But we can actually plug it into this formula to get our answer. So if 7 is n, 7 factorial, I'm losing my ability to draw exclamation points, I know. Over n minus r, 7 minus 3 factorial. So 7 factorial is, let's find out, uh, 5,040, and 7 minus 3 factorial, so that would be 4 factorial. Well, 4 factorial, 4 times 3 times 2 times 1 is going to be 24. And we can just divide this. 5,040 divided by 24, we get 210. So there's 210 different ways for these students to finish first, second, and third. All right, that's where we're going to stop today. I want you guys to try out 7, 8, and 9. It's on the next page. It's leading right up to permutations with repetition. I don't know if we'll get to that. and combinations, because that's probably going to be what we talk about next. But try out 7, 8, and 9, and if you have any questions, shoot me an email. Otherwise, see you guys tomorrow.